Heard you know she is a witch.
Functional programming is a programming paradigm, and the programming paradigm is simply a way of coding, using a specific set of tools and techniques to solve a problem. So basically, choosing a programming paradigm is like choosing a class in an RPG game. Each class has its advantages and disadvantages, depending on the situation, and each paradigm have a different way of thinking and different perspectives. So let's see some examples of programming paradigm to better understand.
Select your character.
Object-oriented programming is a very popular example of programming paradigms. And the user of this class tend to have a very unique way of thinking. They tend to see everything as an object. Another example is the procedural programming class. And they tend to share their data and expose it to the whole program. They are basically communists. Most of them at least.
I am once again asking
to share your variables with us.
And finally, the functional programming class. Well, they are a bit special.
Heard you know she is a witch.
She uses mutable data.
To understand why they are reacting to mutable data this way, and to understand functional programming in general, we need to go a bit technical and see the difference between expression and statements first. In a simple way, the difference between expression and statement is that expression produces a value when evaluated. For example, this method invocation is evaluated to 9, and the evaluation of this one will produce 5. Whereas a statement do not return anything. Instead, they perform an action. It is going to modify a variable or change state. Like here, we are changing the state of the variable a. Wait, you may ask, a plus equal 3 return a value. Well, that is true. But when we add a semicolon after an expression, it becomes a statement, and the returned value will not be used anywhere. So examples of statements are declaration statements like this example, or expression statement like this example, or loops like the for loop and the while loop. Back to program expressions, example of that are method invocation, if the invoked method doesn't return void. Also, arithmetic operators are expressions as well. Back to what is functional programming. Functional programming is a programming paradigm where programs are executed by evaluating expressions without changing the value of variables. In contrast with imperative programming, where programs are composed of statements. For example, we don't have the for loops in functional programs.
But why? Why would you do that? Why would you do any of that?
Be patient with me. We will see the bigger picture soon. So since functional programming are executed by evaluating expressions only, that means that all variables are immutable in our program. And an immutable variable is just a variable that can be changed. That is, once a value is assigned to a variable, this assignment still until the end. And that actually makes all expression predictable. What does that mean? That means that the result of any expression is predictable, without the need of knowing the history of previous execution. That is, if we take any expression separately, we know the result of the execution of that expression. Like the expression 3 plus 2 evaluation is always 5. Another example is this expression that calculates the area of a circle. Will always have the same result for the same radius. And it does not matter what was executed before it, because the variable p will never be changed, since the variables are immutable. Another thing about functional programming is that functions are first-class citizens. That means that we can pass functions around just like other value. Therefore, function can be passed to other function as an argument. We can return a function, and function can also be assigned to variables. Hey, by the way, check gamifyprogramming.com and subscribe to the channel if you are not subscribed yet. In the website you can learn more about functional programming and improve your coding skills in general. By developing a habit of doing small exercises daily, you will become significantly better developer. You can also track your achievements during this journey by checking the stats and achievements. Why functional programming? I think the best way to answer this is by checking some real life success stories. And I think the best example that we can start with is Ericsson and their functional programming language Erlang. The story starts when the telecom industry started to change and telecom operators start to have multi-service networks instead of networks that do one thing only. And Ericsson had to change its old switches to stay in competition. So its computer science lab had to choose a programming language for this new switch software. So they made a list of programming languages that had great features to choose from, but none of them had all the features that met their requirements. And that led to the creation of a new programming language that had it all, Erlang. And with the help of Erlang, Ericsson managed to bring to the market a very reliable multi-service switch, the AXD301. And it was so reliable that was running 99 point... Wait, there is 3 nines missing. And 999. Yeah, it is 9 nines. This is how reliable it was. Erlang offers 9 nines availability because 1. It helps the developer to write a reliable code, thanks to its functional nature, in contrast with imperative programs that are built up by a sequence of statements that are going to change the state of the program. What I mean by a state is all the stored information at a given point in time, like variables, files, or databases. And the problem with imperative programs is that the state of the program can be changed at any time, and it is very difficult to predict when it happens. Sure, in this example it is easy to predict it, but what happens if you have a code that is 1 million times bigger than this one? I see having states like having a huge number of boxes. Each box holds the partial result and the information on how to proceed with the calculation. And during the execution, the content of the boxes will change. And our objective in all this is to put the correct value of the correct type in the correct box in the correct order. So imagine if we have a very big complicated software. Then it is very hard to do that without making any mistake. Not only that, but making any mistake can lead to unwanted side effect, like crashing the system, sending an email, or even launching a missile. Another problem with imperative programming is that testing and reasoning about this type of program is hard, because a lot of times you can take a small part of the program and either test or reason about it, without taking in consideration the state of the whole program. And to test a function, for example, you need to put the system in a certain state, then check the result of the function and the state of the whole system. Also, identifying the side effects of this function is difficult. By the way, the side effects refer simply to the modification of some kind of state. And here we can see why functional programming is more reliable. Because no state is going to be changed internally. Because as we saw before, variables can be changed. And the result of a function depends only on the input. Like in the area function that we saw before. We know for sure that the rest of this function will rely only on the argument, which is the radius in this example. Testing this function is easier as well, because we don't have to put the software under test in a pre-state to test any pure function. because they don't have any dependency on the program state. And the pure function is simply a function that returns always the same value for the same argument, like in the area function here. The function will always return 78.53 if the argument which is the radius equal to 5. And second, a pure function does not produce a side effect, that is, a function that will not change some kind of state. With that being said, let's jump to the second example, WhatsApp. The next example story started in 2007 when two developers from Yahoo left their job to travel South America, but soon their savings started to run in low, so they had to find a job, and they applied to join Facebook, but their application was rejected. But it wasn't that bad, because in 2009 they created their own company. They called it WhatsApp. Then they sold it to Facebook for $19 billion in 2015. And the crazy thing about it is that at that time they had only 35 engineers for 450 million users, and they were doing basically the job of the 300. Thanks to Erlang that have a great support for concurrency and parallelism due to its functional nature. To see why, let's check the problem of concurrency in imperative programming first. Deadlock and erase condition are the biggest problems in imperative programming, and these problems occur when multiple threads read and write to the same data. For example, we have two threads that have to update a counter of how many requests that have been handled by the system. The first thread reads the value of the counter, which is 0, and before it add 1 and write the result, the second thread will read the value of the variable, which is 0. And that will lead to having a wrong value, because both of them will write 1 at the end. But in a pure functional code, this problem does not exist, because we don't have mutable data, as we saw before. Variables are read-only. Erlang is good for rapid developing as well. According to Francesco Cesarini, the founder of Erlang Solutions, Erlang code is 4 to 10 times shorter than C, C++, or Java. Now let's see the last example, Facebook. Sigma is one of Facebook's tools to fight against spams that run sets of rules and policies on every interaction that occurs on Facebook. At first, Facebook tried to make this system using a language that they have designed, that is called FXL, but they failed, so they abandoned this new programming language. Then they tried to build this tool once again. But in this time, Sigma was made using Haskell, one of the best functional programming language in my opinion. And the results were incredible, to a point where Sigma was processing more than 1 million requests per second. To better understand how this language helped Facebook, let's see first what happened after Facebook engineers failed to get the result that they wanted. They made a list of features that are needed in a programming language to replace FXL, instead of fixing the problems existing already in this language. In this page on their website, you can see the top 5 features in their list, and you can see that Haskell have these 3 by default. As for the first one, Haskell is statically and strictly typed, also a pure functional programming language, which make it very reliable, and it is one of the reasons that I love Haskell. And if I had to make a tier list for programming language, then I will put it definitely in the S tier, because in one job application technical test I was writing the solution for 3 days in Haskell without running any test until the end. But when I finished the whole code, I ran 100 random tests, and all of them passed in the first run, because strong type help eliminate many bugs before production. Also, we can be sure that the expressions and functions that we are going to reason about are pure. And pure expressions are referentially transparent. That means that expression can be replaced by their value, and the other way around, which give us the ability to claim that expressions are equal. And like mathematics, we can use this equational reasoning to replace an expression with their equivalents. Like changing r multiplied by r expression by another one. We can use this equational reasoning to verify the correctness of the program as well. Back to the list. As for the performance, Haskell code can be optimized and compiled to a native code, which give good performance. And if we take this Facebook project as an example, we can see that Haskell was 3 times faster than FXL for certain requests, and 20 to 30% in general. And the Glasgow Haskell compiler's interactive environment, or GHCI, will check the 5th requirement in the list. As for the last 2, they did not have a problem in achieving them. As we saw before, how functional programming is good for concurrency, so we can check this one as well. And finally, they used the Haskell compiler tool to achieve the last one. By the way, if you are interested in having more details, check the link in the description below. Chapter 3. Improve your coding skills. Functional programming can make you a better programmer, even if you are using a language that is not functional, like Java. And the start of this language can be increased. For example, your code will be more maintainable and readable. Because functional programming is a declarative paradigm. That is, your code will describe what you would like to happen, whereas imperative programming will describe how to do something. For example, let's say you are going to give orders to someone to help you with some boxes. If you are going to do it like you write in imperative code, then it will look something like this. First, take a box. Second, unpack it. Third, check the state of the object inside. After that, check if it has an OK state, then put it in this new collection. And finally, repeat the same actions for each box in this collection. So basically this is how imperative code is written. So why would I tell you that when I can just say unpack the boxes and filter the ones that have an OK state? This is declarative programming. You basically focus only on what to do and not how to do it. So if I want to code this example in both imperative and functional way, then it will look something like this. Basically we have the first function that is written in an imperative way, while the second is written in a functional way or declarative way. And here you can easily see that it is easier to read and understand what the function is doing. Basically we have a collection of boxes that is going to be filtered by passing a function or predicate that is going to test the state of the box after unpacking it and check if it equals OK.
And clearly you can see that you will gain some extra point on maintainability and readability if you master the functional programming skills. Not only that, but you will gain some extra bonus point in parallelism, like we saw earlier.
So let's take this box unpacking example to see how easy it is to have a code that will run in parallel when we use functional programming. And if we add just one word to the code here, the code will run in parallel basically. Without forgetting the more reliability and testability that we will gain as well. Because you will start using more mutable data, and that will make it easier for the developer to test pieces of code separately. If you like the video, then subscribe to the channel. And check the website in the description below, gamifyprogramming.com. You will find some exercises there that is going to help you understand more things about functional programming. You will find also some small exercises there that is going to improve your coding skills in general. gamifyprogramming.com.